Hello, students, and welcome to our algebra lesson today. We have a fun do now. Our prompt today is about awkward moments. We're celebrating National Awkward Moments Day, and it's just something to laugh at and something to just kind of be lighthearted and think about something that could be awkward, but if we look at it the right way, it won't be. Today we're going to simplify radicals, and our essential questions are what are perfect squares and perfect square and cube roots? And how do I simplify perfect and non-perfect square and cube roots? So our assignment today will be to complete our do now, complete 2 work pages. We'll complete our exit ticket, and if you're a distance learner, submit your work on Teams. And if you're in person, you're going to just show me your work, and you'll get credit for participation today. Our homework will be homework 10, simplifying radicals. We're getting close to the end of Unit 6, and we'll start with our polynomials and factoring after this. So we've got a couple of important due dates coming up. We've got our interactive notebook due date. The homework will be due next week, and we have our unit test. So stay current with all of your work. Don't fall behind. If you keep current with your homework, it's going to be very easy to just submit it next week when you need to. We'll get back to our exit ticket in a minute. So today is National Awkward Moments Day. Have you ever done anything awkward? So here are some ideas to get you started. Have you ever called the teacher mom or dad? Yes, that happens. It happens to a lot of us teachers. You see us so much, and then you get caught up in the moment, and we get called mom or dad. Have you ever accidentally taken someone else's paper, maybe even taken it home with you, or gone to the wrong class? These are awkward moments, and we just have to laugh. Now, when others laugh at our awkward moments, why is that? Are they laughing at us, with us, or are they just enjoying the moment? You know, it's embarrassing to have an awkward moment, but the best thing you can do after you've had an awkward moment is laugh along with everybody else and just think, well, I got a good story to tell out of this. Nobody's making fun of you. Everybody's just trying to laugh and just have a good time with life. So don't take it so seriously. When you have an awkward moment, just give it the big oops and move on. So I'd love to hear your thoughts right here. So now let's get on to our lesson about radicals. So first, very basic, we have the parts of the radical. We have the index. We have the radical, or some people call the house. So this is the radical. And then inside the radical is the radicand. Now, if there is no index, and sometimes there will not be a number here, n standing for number. If there is no index, we will assume, it always is assumed, that n equals 2. So when you see this, we're always going to assume this is an invisible 2. So something a little different from the invisible ones that we're used to. If the radical has more than one root, the radical sign indicates only the principal or positive root. So we know what perfect squares are. Those are numbers when multiplied by themselves yield something else. So multiplied together, 1 times 1 equals 1. So we're going to list the first 12 perfect squares. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 81. Or I'm sorry, 64. I skipped one. 9 times 9 is 81. 10 times 10 is 100. 11 times 11, 121. And 12 times 12, 144. So those are the result of something times itself. So let's call this n times n equals a perfect square. So the opposite of a perfect square is the perfect square root. So the square root of 4, well, we know that 2 times 2 equals 4, so the square root of 4 is 2. So what times what gives us 81? Well, that's 9, so the square root of 81 is 9. What times what gives us 484? And that will be, just give me a second, I'm using a calculator here because I don't know that one by heart. We can do guess and check as a way to do this. And that would be 22 times 22. So the square root of 484 is 22. I just figured that out on the calculator. Okay, easy one. The square root of 64 is 8. The square root of 18 times the square root of 4, well, let's evaluate that. That would be 18. The square root of 4 is 2. So 18 times 2 equals 36. And the square root of 36, by the way, is 6, but they chose to write it like this. So 36 is a perfect square. The square root of 36, by the way, is 6. So 3 times the square root of 256 is 3 times 16, because 16 times 16 equals 256. And that would equal 3 times 16, 48. So we have a perfect square root of 121. The square root of 121 is 11, so negative 5 times 11 is negative 55. The square root of 1 over 16 equals 1/4. The square root of 9 over 100, square root of 9 is 3. The square root of 100 is 10. The square root of 25 over 49, the square root of 25 is 5, and the square root of 49 is 7. Now, those are perfect squares and square roots. If you have non-perfect square roots, you have a little bit of work to do. The first thing we're going to do is find the largest perfect square that the radicand, okay, that's the number inside here, 24 is the radicand, that the radicand is divisible by, and break down the radical using this number. Then you take the perfect square root of the perfect square, take the square root of the perfect square, and you pull it out. You pull it out of the radical. And then whatever's left over, you leave under the radical symbol. So if we have a square root of 24, the largest perfect square in 24 is 4. So we can have the square root of 4 times the square root of 6, because 6 times 4 is 24. Well, 4 is a perfect square, so that would be 2, because 2 times 2 is 4, but we'll leave 6 under the radicand, under the radical symbol, excuse me. Now, number 11 is square root of 48. Well, the square root of 48 can be thought of as the square root of 16 times the square root of 3. And the square root of 16 is a perfect square, so that will be 4 times the square root of 3, because 4 times 4 is 16. Number 12, the largest perfect square, is 36, and what would be 36? Square root of 36 times the square root of 2. So the square root of 36 is 6, so that would be 6 times the square root of 2. Number 13 can be thought of, let's see, 63 can be made with 9 times 7, so it can be thought of as the square root of 9, which is a perfect square, times the square root of 7, and the square root of 9 is 3. And then we have 3 times the square root of 7. That is our final answer. Now, the square root of 90 can be thought of as the square root of 9 times the square root of 10. And 9 is a perfect square, so 3 is the square root of 9. So it would be 3 times the square root of 10. And number 15 can be thought of as 25, the square root of 25, times the square root of 7. And 7 is not a perfect square, but 25 is, and the square root of 25 is 5. So that would be 5 times the square root of 7. So let's move down to the next page. And we have, I think, 8 more. I'd love you to try these on your own. Why don't you try this group of 8 and then come back? Okay, so how did you do? So 162 is 81 times 2. 81 is a perfect square, so that would be the square root of 81 times the square root of 2. And the square root of 81 is 9. So we pull that out and multiply it times the square root of 2 for a final answer. 245 can be thought of as 49 times 5. So that would be the square root of 49 times the square root of 5. And the square root of 49, which is a perfect square, is 7. So we would just write 7 times the square root of 5. Number 8, 343. Well, this 343 can be thought of as 49 times 7. So it would be the square root of 49 times the square root of 7. And the square root of 49, which is a perfect square, is 7. So it would be 7 times the square root of 7. I don't need that multiplication symbol. I can just write it like this. Okay, number 19. 117 can be thought of as the square root of 9 times the square root of 13. And 9 is a perfect square, so the square root of 9 is 3. And then we have that square root of 13, and that is our total answer. Number 20 can be thought of, 28 can be thought of as 4 times 7, and 4 is a perfect square. So the square root of 4 is 2. So 2 times the square root of 7. And finally, number 21, 450 can be thought of as 225 times 2. So that would be square root of 225 times the square root of 2. And 225 is a perfect square of 15 times 15. So we can pull that out and say 15 times the square root of 2. So that's the squares, but we also can talk about the perfect cubes. So let's list the first 10 perfect cubes. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 times 4 is 60, or 4 times 4 times 4, excuse me, is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. 9 times 9 times 9 is 729. And 10 times 10 times 10 is 1,000. 10, 1,000. 10 times 10 is 100. 100 times 10 is 1,000. So when we notate the perfect cube root, we have to use an index of 3. The only time we don't have to write the index is for square root of 2. So what we're asking here, number 22, is what times what times what, when multiplied together, will equal 8. And there's only one number that you can put in each one of these little X boxes, and that number is 2. So the cube root of 8 is 2. 2 times 2 times 2 is 8. Be careful, do not confuse repeated addition with repeated multiplication. So the cube root of 729, you would say what times what times what equals 729, and the answer is 9. So now we're looking for the cube root of 24. What times what times what equals 1,331, and that would be 11 times 11 times 11. So that would be 11. So try the next few on your own. In this group, we're going to simplify square roots, but use perfect cubes to break down the radical. So the cube root of 40 can be thought of as the cube root of 8 times the cube root of 5. And let's change our color. And the cube root of 8 is 2, because 2 times 2 times 2 is 8. So we can say 2, the cube root of 5 is our final answer for simplifying the cube root of 40. So the cube root of 500 can be thought of as the cube root of 125 times the cube root of 4. I put a 2 there. I should have put a 4 there. I'm getting a little tired tonight. So actually, let's neaten up my work with this radical. There we go. Okay, this cube root of 125 is 5, because 5 times 5 times 5 equals 125, and then we just leave the cube root of 4 in place, and that's our final answer. So again, you will need calculators for doing this. The cube root of 162 can be thought of as the cube root of 27 times the cube root of 6. Well, the cube root of 27 is 3, so we would have 3 times the cube root of 6. Number 31, we're looking for the cube root of negative 16. So we can think of that as the cube root of 8 times the cube root of 2. And the cube root of 8 is 2. And remember, negative times a negative is a positive. So we have 2, the cube root of 2 as our final answer. Cube root of 432 can be thought of as the cube root of 216 times the cube root of 2. So we'll put it all together. The cube root of 216, what times what times what equals 216? And the answer would be 6. 6 times 6 times 6 equals 216. So we pull the 6 out, and we're left with the cube root of 2 inside, and that's our final answer. The number 33, 320 is 64 times 5. So we would have a negative 64, and that would be a cube root times the cube root of 5. And the cube root of 64 is 4. 4 times 4 is 16. 16 times 4 is 64. But this is a negative 64, so our cube root is negative 4. And then we have cube root of 5. And that's our final answer. Number 34, we're asked to find the cube root of 54, which can be thought of as the cube root of 27 times the cube root of 2. So the cube root of 27 is indeed 3, because 3 times 3 times 3 equals 27. We put the radical with the 2 next to it, and that's our final answer. And number 35, the cube root of 96. Well, 96 can be thought of as 8 times 12. So we have the cube root of 8 times the cube root of 12. And the cube root of 8 is 2. So we pull that out, and we leave the cube root of 12 in place. And finally, number 36, negative 875, we can think of that as negative 125 times 7. And we can pull out the 125 because the cube root of negative 125 is negative 5. So it would be negative 5 times the cube root of 7. So that's the last problem. They take a little bit of getting used to. Don't do them tired like I do. For homework, you have, here's your make your own emoji. Here's a fallen phrase. These are really fun. And here is your homework after this, 1 page. So let's go back to the exit ticket. List the first 10 perfect squares and cubes. So perfect squares, we'll label them. So they would be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 124. Now the perfect cubes are a little different. Perfect cubes are 1, 8, 27, 64, 125, 216, 343, 512, 779, and 1,000. So that's it. Keep practicing on those radicals. Do the 1-page homework. Have fun with the little kind of surprises I put at the end of the lesson. But most of all, practice, 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 because when you do, you'll be great.